Hi, this is Alex from devstories.eu. NVIDIA NeMo Guardrails, Episode 7 of 10. Giving a language model access to execute database queries is like handing the keys to your database to a stranger. You tell the model to fetch user data, but a clever prompt tricks it into appending a command to drop a table. Securing agentic workflows with execution rails is how you stop autonomous agents from compromising your backend. Most guardrails focus on the chat response. They stop the model from using bad language or going off topic. Execution rails do something completely different. They protect the tools the agent uses. When an agent decides to use a tool to run a dynamically generated Python script or execute a SQL query, the execution rail intercepts the payload exactly at the handoff point, right before the tool actually runs. NeMo Guardrails handles this validation using YARA rules. YARA is a pattern matching engine traditionally used by cybersecurity analysts to identify malware based on specific textual or binary signatures. In this framework, NVIDIA provides a predefined catalog of YARA patterns built specifically to catch language model vulnerabilities. The Guardrails engine passes the tool input through these YARA rules to look for known attack signatures. This catalog targets 4 specific threats. First is SQL injection, where the model generates database commands containing malicious modifications. Second is code injection, where the agent tries to execute unauthorized system commands inside a dynamically generated Python script. Third is template injection, where an attacker manipulates server-side rendering engines. Finally, it detects cross-site scripting, blocking payloads designed to execute malicious scripts in a web browser. Consider an agent tasked with taking a user request, writing a Python script to process some local data, and running it. If a user hides a system command to expose environment variables inside their prompt, the language model might blindly include that command in the final Python script. The execution rail catches this. It scans the generated Python code, matches the YARA rule for code injection, and flags the payload before the execution engine ever sees it. When the system detects a malicious pattern, it takes action based on your configuration. You have 2 choices. The first action is reject. This completely blocks the tool execution. The workflow stops, the malicious code never runs, and the system returns a safe response. The second action is omit. This tells the guardrail to strip the specific malicious string out of the payload, but allow the tool to execute whatever is left. Choosing between reject and omit depends entirely on the tool. If your agent is running a SQL query against a database, reject is the only safe choice. Omitting a string from a complex SQL query will likely result in malformed syntax or unpredictable data access. Omit is generally reserved for basic text processing tasks, where removing a bad string still leaves a usable, safe payload. You configure these protections directly in your YAML files by enabling the Agentic security rails and mapping them to specific tools. The underlying YARA engine does the heavy lifting, matching the predefined patterns without requiring you to write custom regular expressions. Execution rails treat the language model as an untrusted user, forcing you to validate every single command it generates before it touches your infrastructure. Thanks for listening. Happy coding, everyone.